Okay, let's just dive right in. Look, you've probably sent, a dozen messages already today, and you just assume they're private, right? Well, I've got some kind of bad news for you. The very foundation of pretty much every messaging app out there, yeah, even the popular ones, is built on a massive, fatal flaw. We're talking about the central server. And this isn't some minor tech detail, okay? This is a single point of failure. It's a giant honeypot for anyone who wants to snoop on you. And it's basically a kill switch for all your communication. So today, we're doing a full architectural teardown of an app that doesn't just, put a Band-Aid on this problem. No, it completely obliterates the entire concept.
So when you send a message, what do you picture? You probably think it goes straight from your phone to your friend's phone, right? Like a direct line. But that's not what happens. Not even close. The reality is, with apps like WhatsApp, Signal, even Telegram, every single thing you send, every word, every photo, every single call, it all takes a big detour through some massive server farm that they own and they control. Yeah, your private conversations, they're living on somebody else's hardware. And that right there, that is the fundamental vulnerability that NyxChat was built to destroy. It asks a pretty wild question. What if we just got rid of the servers? Like, completely?
All right, so here's the game plan for this deep dive. We're going to go layer by layer. We'll start with the whole illusion of privacy thing with servers, then we'll jump into the serverless revolution to see what NyxChat is all about. After that, we're dissecting its unbreakable network, poking around its post-quantum crypto fortress, and even checking out its physical and performance defenses. And to wrap it all up, we'll look at why being open source is the ultimate trump card. It's going to be a ride, so buckle up.
So, let's get real. Why are servers such a big deal? Well, for one, they create these massive, centralized honeypots of metadata. Seriously, think about it. Who you talk to, when you talk to them, where you are when you talk, for how long, all of that data is sitting in one place. It's an absolutely irresistible target for surveillance, right? And it's a single point of failure. When these servers go down, and they do, they can silence activists or just bring global communication to a grinding halt. Even with end-to-end encryption, which is great, the server is still a bottleneck. It's a huge critical vulnerability.
And this is NyxChat's answer to all of that. You see that key phrase right there? Zero server infrastructure. That's not marketing fluff. It is a fundamental, core architectural commitment. This isn't some app where they just bolted on privacy features at the last minute. Nope. This is a complete paradigm shift. It was designed from the ground up, from the silicon up really, to completely remove that central point of control. It's about making sure your messages actually belong to you and only you.
Okay, but hold on. How is that even possible? I mean, how do you build a global messaging system without some kind of central brain telling all the messages where to go? This is where the engineering gets just ridiculously clever. See, NyxChat doesn't just rely on one way to talk. It's more like a hydra. You know, the mythical beast? It's got 5 different networking heads.
It's basically a digital chameleon, a multi-transport system that just adapts to whatever environment it's in. So let's say you're on your local Wi-Fi. It uses mDNS. That's just a fancy way of saying it automatically finds other phones on the same network. Zero config needed. What if you're completely off-grid? No problem. It spins up a Bluetooth mesh network, turning all the phones around you into little message relays. Need to find someone on the other side of the planet? It uses something called a DHT, a distributed hash table. Think of it like a decentralized phone book for the whole world. Got a big file to send? It'll use Wi-Fi Direct for super high speeds. And if all of that fails, it has an escape hatch, an optional encrypted relay through Tor. You see? It's not just a messenger. It's a living, breathing, adaptable network.
Okay, let's really unpack that networking layer, because this is where the real magic happens. We're not just talking about sending a text message here. We're talking about creating a resilient, self-organizing network that can survive pretty much anything, from your home internet going down to a complete total communications blackout.
And here's how all that tech actually works in the real world. That mDNS thing, that's you in a coffee shop, and the app just automatically finds your friend on the same Wi-Fi. No setup, no fuss. The BLE mesh? That's the real hero for protesters or in disaster zones. It creates a network literally out of thin air when the internet is just gone. The DHT is its global decentralized address book. And Wi-Fi Direct? That's for the heavy lifting. You know, when you want to send a huge video file straight from your phone to theirs without ever uploading it to the cloud. And then there's the Tor relay. That's the ultimate escape hatch, an encrypted bridge to the rest of the internet when every other direct path is totally blocked.
And check this out. That Bluetooth mesh, it isn't your standard everyday Bluetooth. It's using this special feature in Bluetooth 5.0 called coded PHY. Now what the heck is that? Well, in plain English, it means the app chooses to be a little bit slower, but in exchange it gets a massive 4 times increase in signal range and reliability. We're not talking about connecting across a room here. We're talking hundreds of meters, outdoors, from one phone directly to another. For any off-grid situation, that is an absolute game changer.
But, a network of devices is totally useless if your messages can't actually find where they're going. So for this, it uses this really smart hybrid routing protocol. The best way to think of it is like a GPS that has a backup plan. The first part is kind of like Google Maps. It's a smart system that figures out the fastest, most efficient path through the mesh in real time. But what happens if the network is all broken up, with phones connecting and disconnecting? That's where the backup plan, called spray and wait, kicks in. This is brilliant. It's like sending out a few trusted couriers, each with a copy of your message. You don't know for sure which one will make it, but by strategically spraying a few copies out there, you basically guarantee one of them will eventually find its target, even if it takes a while or the network is super spotty.
Okay, now this is one of my favorite features. It's so clever. How do you create a group chat for everyone in a specific area, like a park, without making everyone broadcast their exact GPS coordinates to the world? Well, you use something called geohash channels. Here's how it works. Your phone takes your location, does some math, and spits out a hash, just a short string of letters and numbers that represents your general area. Your actual precise coordinates never leave your device. Now, anyone else nearby whose phone calculates the exact same hash gets automatically dropped into the same anonymous chat room. So you get a location-based chat without ever giving up your location privacy. How cool is that? Just brilliant.
So we've got an unbreakable network. But that's useless if the messages themselves can be broken, right? So let's move up the stack and talk about the crypto. And this is where it gets really interesting, because NyxChat isn't just built to protect you from the threats we have today. It's built to defend against the threats of tomorrow.
You have to understand, the most sophisticated attackers out there, they're not even trying to break your encryption today. It's too hard. Instead, they're doing something much scarier. They are recording all your encrypted messages, storing them on massive hard drives, and just waiting for the day a quantum computer is powerful enough to crack it all wide open. This is a real threat. It's called a harvest now, decrypt later attack. And NyxChat is explicitly engineered to make that impossible.
So how do you actually defeat a future threat like that? Well, it uses this brilliant belt and suspenders approach. It's called a hybrid key exchange. Think of it like this. You have a door with 2 completely different locks on it. One is a normal key lock, and the other is a futuristic combination lock. You need to pick both to get in. So first, the app creates a key using X25519. That's the current gold standard. Super hard for today's computers to break. At the exact same time, it creates a second key using a post-quantum algorithm called Kyber 768. This one is based on math problems that we believe even a powerful quantum computer won't be able to solve. Then it smashes both of those keys together into one super key. What does that mean? It means an attacker would have to break both the classical crypto and the quantum-resistant crypto to read your messages. It's basically a cryptographic firewall against the future.
And as if that wasn't enough, on top of all that quantum resistance, it also uses the legendary signal double ratchet protocol. This is what gives you perfect forward secrecy for every single message. Just imagine you're having a conversation, but the lock on the door changes with every single sentence you speak. So even if an attacker somehow, miraculously, steals the key for one of your messages, it's instantly useless, because the very next message uses a brand new, totally unpredictable key. The session is constantly healing itself. A single compromise can't burn down your entire conversation history. It's incredible.
All right, so the network is rock solid. The crypto is quantum proof. But what about the most common threat of all? What happens if someone gets their hands on your actual phone? And for that matter, how does all this complex tech run without just draining your battery in 5 minutes?
Well, NyxChat plans for the absolute nightmare scenario, someone forcing you to unlock your phone. It has something called a duress pin. You enter this special pin, and it doesn't just unlock the app, it opens a totally fake decoy version of the app that looks completely real. And if that's not enough, there's the panic wipe. This is the nuclear option. If someone tries and fails the password 5 times, it doesn't just lock them out, it irreversibly nukes everything. Every key, every database, gone forever. For the attacker, it's game over.
But listen to this, because this is the truly mind-bending part. It's all about data resilience. So the local database is heavily encrypted, right? But if that database ever gets corrupted for any reason, the app's first move is to just delete it. Now, with any other app, that's a disaster. You'd have to set everything up all over again. Not here. Instead, it reaches into your phone's hardware secure element, that little Fort Knox on the chip itself, and uses the keys stored there to perfectly rebuild your entire cryptographic identity from scratch. You don't have to do a thing. Your identity literally survives a total data apocalypse on your phone.
And what about performance? It's just as smart there too. All that heavy lifting, the crypto, the mesh routing, it all gets offloaded to background threads. This keeps the user interface buttery smooth. And get this, it actually uses your phone's accelerometer, the thing that detects movement, to figure out when your phone is just sitting still on a table. When it is, it pauses the constant Bluetooth scanning, which saves a ton of battery life. And finally, a persistent service keeps the whole mesh network alive in the background, so it's always ready to go even when the app isn't open on your screen.
So there you have it, this incredibly sophisticated system. It's serverless, it's quantum resistant, it's self-healing, it's a mesh networking marvel. But with any tool that promises this much security, you have to ask the most important question of all: how can we actually trust it?
And the answer is a fundamental principle of all good security. You don't have to trust the people who made it. You just have to trust the code. This whole project is licensed under the GPL v3.0, which is a fancy way of saying every single line of code is open for you, me, and anyone else to look at. Security researchers can audit it, the community can contribute to it. Because in the world of real cryptography, there is no such thing as security through obscurity. You can't have any secrets in the code itself.
And hey, for any of you developers watching right now, if you take a quick peek at the tech stack, you'll see this thing is built on a really modern and robust foundation. It's mostly written in Dart using the Flutter framework. And that's a really smart choice because it means they have one single high-performance code base that works on both Android and iOS. That ensures everyone gets the same features and the same security. This isn't just some weird science project. It's a piece of modern, well-architected software.
So all of this, it leaves us with one final and really crucial question. Look, NyxChat isn't just another app you download. It's a working proof of concept. It's a powerful architectural argument that says, yes, a truly private, resilient, and user-owned internet is actually possible. It's not some sci-fi dream. It's being built right now. The biggest takeaway from all this isn't just about this one app. It's the realization that the tools to reclaim our digital freedom, to build a better internet, they're already here, and they are way more powerful than you might think.